Okay, we've got this LCR circuit here with a inductor, capacitor, and the associated resistance within that circuit. Calculate the necessary quantities to explain whether the inductance must be increased or decreased to bring the circuit to resonance. Remember, for resonance, the reactance must equal 0. So that is, the inductive reactance has got to be equal and opposite the capacitive reactance. And we're given so far that the reactance of the capacitor is 20 ohm, and we need to see what the reactance of the inductor is. So let's use our formula for reactance of inductor. 2 pi FL is equal to 2 times pi times a frequency of 200 Hertz times 10 millihenries. That gives us a reactance of 12.566 ohm. Remember, reactance is an impedance, so it's measured in ohm. However, we've only got two significant figures, so we're going to call that 13 ohm. So what we've got is capacitive reactance 20, inductive reactance 13. So we need to find a way of increasing. We need to increase the inductive reactance. And how do we increase the inductive reactance? By increasing the inductance. Increase inductance, we get increased reactance, and we should be able to increase it up until it's this equivalent to the capacitive reactance. Calculate the inductance of the inductor at resonance. At resonance, the inductance of the reactance of the inductor will equal the reactance of the capacitor, which I've already said is 20 ohm. So let's use our formula then. XL equals 2 pi FL, and we know that the reactance is 20, 2 pi times 200 times L. Therefore, the inductance that makes that true is 16 millihenries. To calculate the maximum possible current in the circuit, that occurs when the inductive reactance equals the capacitive reactance, which means the impedance in the circuit is equal to the resistance. Let's have a look at that. The way we calculate impedance is we add the inductive reactance to the capacitive reactance and then add it to the resistance. We can see XL equals XC. So these reactances will cancel one another out. So we will simply be left with resistance, and that's the smallest that the impedance can be. It's the lowest value it can have. So using this as the resistance at the point where we will have lowest resistance will give us the maximum current. So that particular resistance of that resistor is 20 ohm, R equals 20 ohm, and the current is equal to voltage over resistance, Ohm's law. And the voltage in this case is 5 volts, and the resistance is 10 ohm, so the current is 0.5 amp. Okay, that'll do.